This is going to be the solutions for the proof guide. Okay, so I'm not going to do full-on two-column proofs. I already did those, and I'll post those along with this video. What I'm going to do in this video is just kind of go through making the marks and giving the sort of the logical explanation of why some of these theorems are true, and then you guys can read the two-column proofs on your own time. So let's look at the first one. The first one says that line segment XR is parallel to SY. So XR parallel to SY. Okay, now those two being parallel should make you think of possibly alternate interior angles, corresponding angles, some of those transversal type theorems. Okay, it also says that RS bisects XY. So that means that these two lengths are congruent. It wants us to prove that triangle RMX is congruent to triangle SMY. Okay. Now, when we're trying to prove two triangles congruent, we usually need three pairs of parts to be congruent, and then we apply one of our shortcut theorems. Now, at the moment, between these two triangles, the only thing we have is the line segment XM being congruent to MY. But we can also say that these two angles are congruent. Okay. And then if we go back and use the fact that XR is parallel to SY, let's see, and that RS is a transversal of those two lines, then we can also say that this angle right here in green and this angle right here in green are congruent because they are alternate interior angles. So I'll just draw that out here on the side with less stuff in the way. Those are the two parallel lines and then the transversal. And then I'm just saying that this angle and this angle are congruent to each other because they're alternate interior angles. Okay, since they're congruent, now this means that we actually have three pairs of parts between these triangles being congruent. Okay, we have, let's zoom in a little more. We have this angle, and this side of that triangle, of the triangle on the left, being congruent to this angle, and this side of the triangle on the right. And this is angle, side. So we have two angles and an unshared side being congruent to each other in two different triangles. So these two triangles are congruent by angle, side. So I put together a two-column proof of that, and you can check that out. Probably after the video. You probably want to see these explanations before you look at the two-column proofs. Also, the two-column proofs are just already made and already there, and all the markings are done. So if you just go and look at that, you're just going to be looking at a page full of markings. Whereas if you watch these videos first, you'll see how the markings come one by one. All right, let's look at number 2. Number 2 says DC is parallel to AB. So this angle right here is parallel to this angle. DC is congruent to AB. They're also telling us that they are congruent to each other. So not only are they parallel, but they're also the same length. And it wants us to prove that AD is parallel to BC. Okay. So we want to prove that this is parallel. We don't know that they are. Okay. So one way to prove that two lines are parallel is by using the converse of some of our transversal theorems. So we have like the alternate interior angles theorem, we also have the converse of the alternate interior angles theorem. So if we can show that alternate interior angles here are congruent, then that would prove that the two lines are parallel to each other. Now, I actually don't remember how I did this one. So I'm just going to go ahead and start trying things out. This is not a good idea, probably. I should probably open up the... Let me see if I can... Yeah, hold on. Sorry. Let me search up the solutions that I had made. Oh no, they're on here. On the... Okay, well I think it's worth it probably to just stop this for a second and go look for the solutions. Oh no, but then I have to scroll through all my pictures. Never mind. Let's just do this. We'll figure it out on the fly, just like you had to do it. Okay, so again, we know DC is parallel to AB. We also know they're congruent, and we got to prove that AD is congruent to CB. All right. So you usually want to think in terms of the triangles. So at the moment, between these two triangles, I'll highlight them in red, DAC and CBA, we know one pair of parts between them that are congruent. Now, we also know that this blue highlighted part is also congruent. And because DC is parallel to AB, that means that this angle 2 here is alternate interior with angle 4. And that means that the two triangles are actually the same. They're, congruent to each other. Why is that? Because we have this side, this angle, and this side being congruent to this side, this angle, and this side. So by side angle side, the two triangles are congruent to each other. Okay. Now, let's erase some of this mess so we can get to the important part. So now that we know the two triangles are congruent to each other, let's erase some of this stuff. Let's erase all of it, actually. The two triangles are congruent to each other, with this angle being the same as this one. Now, furthermore, this angle and this angle have to be congruent to each other. Now, if those two angles are congruent to each other, and those two red angles, 1 and 3, are created from this line and this line, and this transversal, right? Notice the red angles are created from those two blue lines, this one and this one. And then this red angle is created from this blue one and this blue one. So they look like they're alternate interior angles, right? So, and remember, we were trying to prove that these were parallel. We're trying to prove that DA was parallel to BC. Well, now we get to say that they are parallel because 1 and 3 are congruent. So, and that's called the converse of the alternate interior angles theorem. So AD is parallel to BC because of the converse of the alternate interior angles theorem. So notice first we had to prove that the two triangles were completely congruent to each other in order to get this information that 1 and 3 are congruent to each other. But then once we have that, that implies that these two lines are parallel to each other by the converse of the alternate interior angles theorem. Okay. Delete screenshot. All right, let's look at number 3. So number 3 says angle 5 and 6 are congruent. So this angle and this angle are congruent. AT is congruent to HT. AT is congruent to HT. Prove that MT bisects AMH. So in green, what we want to prove is that MT bisects AMH. So we want to prove that this angle, well, we should be more precise. Yeah, we want to prove that this bisects AMH. Okay. So once again, we're going to use triangle congruence to do this. So notice the two triangles in the picture, MAT and MTH. Notice those two triangles. One's on top, one's on bottom. Between those two triangles, we have one pair of sides congruent. We have, which I had already marked in blue. It's this. It's AT being congruent to TH. Furthermore, we have that angle 3 has to be congruent to angle 4. Now, why is that? The reason that has to be true is because notice what is this entire angle right here in black? That's 180. And then on the bottom you have kind of the same thing going on, black. Now we already know that these two blue portions are the same. So that means that these red portions have to be supplementary with the blue portions. And the blue portions are the same degree measure, so the red ones also have to be the same degree measure. Okay, so let's erase some of this. Okay, so now between these two triangles we have a pair of sides and a pair of angles congruent. And then this side right here is congruent for both triangles because it's the same side. It's the same side for both triangles. So by side angle side, these two triangles are congruent to each other. So let me highlight the triangles. Let's use purple. So this triangle right here is congruent to this triangle in purple right here. Those two triangles are congruent. The reason is because we got side, angle, side, and side, angle, side. So by side, angle, side, these two triangles are congruent. That implies, let's do some erasing here. That implies that in particular, these two angles have to be congruent to each other because the triangles are congruent and these two angles correspond to each other. Okay, remember what we were trying to prove? We were trying to prove that MT bisects AMH. So we're trying to prove that this line right here bisects this larger angle. Well, it does because by definition, an angle bisector like MT has to create two equal angles from the original larger angle, AMH. It creates two equal size angles. So it is a perpendicular bisector. It is an angle bisector. Okay, so that's kind of like the logic with the markings, and then you guys can go look at the the 2-column proof to see how it works. Some of these are really long, and some of them are pretty different than what we did on IXL, which is why I really like this proof guide. It has a lot of interesting proofs. Okay, let's do number 4. Some of these are pretty hard. Right, number 4 says, given angle 1 is congruent to angle 2. Okay, so this is the same as this. Triangle bug is isosceles with base BG. So BUG is isosceles, and the base is BG. That's telling you that it's this angle and this angle that are congruent to each other in the larger triangle BUG. Okay. It wants us to prove that UA is perpendicular to BG. Okay. So, at the moment, also notice, see, what I wanted to do was say that this side is congruent for both. And then we would be almost done there, because then we would say that the 2 triangles are congruent to each other by angle, side. Like this angle, and this side are congruent to this angle, and this side. But they explicitly tell us you may not use the reflexive side UA in your proof. So they don't want to, whoever wrote this up doesn't want us to do that. They want us to prove it in another way. Okay, so what else can we do? I don't remember how I did it, so I'm just kind of thinking of it on the spot. Well, if we knew, okay. All right, so since the triangle BUG is isosceles, not only are these 2 angles congruent, but these 2 sides have to be congruent too, this one and this one. Because isosceles triangles have 2 sides congruent. Okay, so now we can tell that the 2 triangles are congruent by angle, side, angle. So we got this angle, this side, and this angle being congruent to this angle, this side, and this angle. So the 2 triangles are completely congruent by angle, side, angle. Now, we're not done yet, because what we want to prove, we don't want to prove that the triangles are congruent. We want to prove that UA is perpendicular to BG. So we're still not done yet. But we're almost there. Since the 2 triangles are congruent, in particular, this angle in purple has to be congruent to this one. Oh, I'm kind of cheating. I put the little purple boxes already, but we have to prove that they're right angles. That's what we want to show. So for now, we'll just put arcs, and then we'll go through the logic of why we know they have to be 90 degrees. So the logic for that is, if the whole thing's 180 and they both have to be equal, it means you have to split 180 between 2 angles. That means they each have to be 90 degrees. So now you can go ahead and put the box, the little 90-degree box. Okay. One more step. We know they're 90. How do we know they're perpendicular? Because that's the definition of being perpendicular. So the last line in the proof will probably be like definition of perpendicular line.